Hi and welcome to my new video. Today I would like to demonstrate a feature added in Apache Spark 3.1 which is called stage level scheduling. And to demonstrate this feature, which as for this recording is only available for the RDD API, I will use a very sample code where I'm starting by creating some basic RDD that I will later group by and count. And the point is that these two operations don't require the same type of hardware. So you can see that for the case of group by stage, I would like to have some executors and tasks with 2 cores and 1 CPU and some off-heap memory. So, but of course this resource profile is arbitrary, it's only there for the demo purposes. And the same, you can see that for the count, I'm expecting some other cluster configuration with 4 cores and 1.2 gigabytes of memory. So later I will do some slipping just to keep Spark UI open for some investigation, and later I will stop the context so that everything can clean up. I will just to show you also another thing which is required for running Apache Spark on Kubernetes, which is the Docker image. So I'm using here the base image offered by Data Mechanics, which is a company offering also a serverless Kubernetes solution. And I'm using the most recent version as of this recording still of Apache Spark. So I'm declaring the workdir for the application code, and later I will copy the jar that I will build with some clean install command. So let me start, let me take some commands and execute the demo. So I will start, so I already started Minikube and Minikube dashboard. Now I will build the project, and I will also take the command to build the Docker image. So the project should be built very soon. It's not complicated, doesn't have a lot of dependencies, so it shouldn't take a long time to build it. And meantime, maybe I will just to explain how to create these resource managers, the resource profiles, sorry. Of course, you can use, so to create the resource profiles, you can use the resource profile builder, where you define some requirements and the specifications of these requirements still in this builder design pattern mode. So the project has just built, and now I will open my terminal and build the Docker image. I will also grab the command to create the archive. Okay, and I will now create the archive with this Docker image and upload it to Minikube. Okay, and now I will upload this archive to Minikube and also verify if it succeeded. Okay, and you can see that we have our stage level scheduling demo last image uploaded to Minikube. So now I should have run all these commands, but I have already done that, so they will fail. So I already have this namespace, so I can set it to the current context of this LI. I also created the service account, so there and associated bindings. So okay, that's completely fine. In the next step, I will need to get the Kubernetes master address, which is 172.0.0.2 at the end. And now I will submit my Docker image from a local Apache Spark distribution I've downloaded with this command and with this master ID, and the code is currently is running. So now I can check I will show you the Kubernetes dashboard. You can see that we have a new driver which is running. I will get the name of this driver and enable the port forwarding for Apache Spark UI. So for Apache Spark UI, yeah, that's correct. And so after enabling this Spark UI, we can check. So after enabling this Spark, the port forwarding, we can access the Spark UI on our local machine, and you can see that we have two stages. So I was not wrong by defining two resource profiles, and one stage has already completed, and you can see that it has some resource profile ID associated, and remember the number of this resource profile is 1. So the stage number 2 should, you can also see that we had one executor for this stage, for the previous stage, and the second executor for the next stage that should start very soon, because the executor is already there. Let's give him a few minutes. Okay, I mean, maybe just need to, so I only needed to restart the port forwarding. So let's check the count. Yeah, and the count stage has a different resource profile with the number 2, and you can also see that we have the same the executor for this resource profile just here. And quite important thing from the documentation about this feature with Kubernetes is that in order to use stage resource scheduling, you will need to enable the dynamic resource allocation. So you remember in Yarn, you can use external shuffle service, but it's not available for Kubernetes resource scheduler. And that's the reason why you will need to use the feature called shuffle map shuffle file tracking, something like that. Globally, the feature will track which executor stores the shuffle files used in the next stage, and as long as this executor may be needed, it will not be destroyed, and it can lead to some situations where a Kubernetes will keep more executors online than actually needed for the computation. But it's all explained in the documentation and also in the article which is linked in the description of this video. So I invite you to read it. You can see that our job completed, I think. Yeah, it's completed. You can also observe the activity for the executors in the timeline, and you can also observe it, analyze it in the logs of the driver. So now I will access the logs of the driver and look for resource profile. So it all started with some default resource profile, whose specification you can see just here, and later we declared two resource profiles with the ID1 and with the ID2, as you can see, having two different specifications, which are these ones. So one executor with 2 cores and another with 4 cores. And now when Apache Spark uses these executors, you can see that it's the executor pod allocator class of Kubernetes that will use the resource profiles. The first resource profile for the map shuffle stage, and the second resource profile for the result stage, which takes the shuffle files and generate the final output with the count action. And globally, you can also notice some registration activity, and that's all. So you have two ways to investigate and analyze what happens with these resource profiles, either from Spark UI or from the logs, or both if you prefer. But anyway, that's the whole idea of resource profiles. So in a nutshell, you can use it to define different hardware configurations that you may need for different stages. So the example which is given in the Jira proposing this change is that you can have a job composed of two main blocks: the block for data preparation, kind of ETL, and the block of machine learning. And the point is that these two blocks may not need the same resources. So for example, you may need some GPU for the machine learning, but you may not need it to do the data pre-processing, meaning that without the resource profile, the GPU will be idle during this first big step, whereas with the resource profile, you will be able to separate these two concepts and activate the GPU only in the machine learning part. But of course, as I said, it's only available with RDD API and also has some gotchas, like the number of executors that can be much bigger than currently needed in the computation, but it's all explained in the documentation and also a bit deeper in the article, which is linked in the description of this video. It was Bartosz Konieczny from whatgeekforcode.com. Thanks for watching.